Hello guys, I want to take this chance in a very special way to welcome you once more for a continuation of our study on a topic, chemistry of metals. Remember, in our first lesson we looked at the introduction of chemistry of metals. Second lesson we looked at the extraction of lead metal from its ore. Our third lesson we looked at the extraction of iron metal from its ore, and our previous lesson we looked at the extraction of copper metal from its ore. Today, our fifth lesson will be extraction of zinc metal from its ore. Number one, we must know the two major ores of zinc. Number two, we must know the minor ore. And number three, the major impurity which exists in these ores. The major ore of zinc, we have number one, calamine, zinc carbonate. Number two, we have zinc blende, which is zinc sulfide. So the major ore we have, number one ores we have calamine, zinc carbonate. Then we have zinc blende, we have zinc blende, which is zinc sulfide. Now we have the minor ores. We have minor ore. It is only but one. Zinc 2 oxide. Which is given as shown in the bracket. Now, the major impurity in this case is lead 2 sulfide. Lead 2 sulfide. This is the major impurity here. Now, after having known the major ores and the minor ore of lead, the question is, how can we obtain these ores? I said before in the introduction part of chemistry of metals that metals exist naturally underground. Therefore, they are mined from the ground. So, for example, if the only ore that exists in a particular place or a particular ground is calamine, it is mined. If it is zinc blende, the same applies. Now, since zinc metal is needed in abundance, it means we will go for the major ores. Now, after having known the major ores, what begins is the mining of the ore. So, our flow chart will illustrate how extraction occurs right from the mining part. So we have the ore is mined, the mining of the ore. The mining of the ore is done. And once the ore has been mined, what follows is the crushing and grinding of the ore to increase the surface area for subsequent reaction or to increase the contact between the ore and the reactants, other reactants. So we have the grinding and the crushing of the ore. After the ore has been ground into fine powder, what follows is the purification of the ore by a special process known as froth flotation. So we have got froth flotation to remove some impurities. And as I mentioned before, I said that this is a process by which a frothing agent, which is a mixture of oil and water, is passed into a column containing the ore which has been crushed. Now this oil and water mixed together will remove the impurities and making them to sink, leaving the froth floating. Now the froth contains the ore which we now need for the extraction process. Now, after we have removed the impurities, now we have the ore with a small amount of impurities. We have removed most of the impurities. Now the ore which has undergone purification can be subjected to the processes of extraction, as our aim is to get a metal from its ore. Now, you must know the ore that we are dealing with. If you are dealing with zinc sulfide, then after froth flotation, it is taken to a roasting chamber. So, but if you're dealing with calamine, which is zinc carbonate, it means it is taken to a kiln where it is decomposed first to form zinc oxide. Remember, anytime you want to obtain a metal from its ore, it must be converted to an oxide of the same. So if you have a compound which cannot be roasted by reacting it with oxygen, then it has to be decomposed. And when it is decomposed, it must form an oxide. So what happens? For example, assume the ore which is available is zinc sulfide, then zinc blende, for example. It is taken to the roaster. It is taken to the roaster. Now the roaster, oxygen is added. Now oxygen will react with zinc sulfide to form zinc oxide and sulfur 4 oxide. So at the roaster, zinc sulfide reacts with oxygen gas to form zinc oxide and sulfur 4 oxide. You balance by having 2, by having 3, and by having 2, and by having 2, and then you must obey the rules in chemistry by having the right state symbols. Now we will be having sulfur 4 oxide given out. Now sulfur 4 oxide, as I've been saying, should not be released into the atmosphere because of its acidic property. It is able to form an acidic solution when it reacts with moisture and even the rainwater, which will have adverse effects like leaching the nutrients in the soil, and also corroding ion sheets, and again even interfering with aquatic life as well as causing respiratory problems. So I will be having zinc oxide. We'll be having zinc oxide now. But if the major ore involved in the reduction process or in the extraction were, for example, calamine. Calamine is zinc carbonate. It is also converted to zinc oxide if it were used through decomposition. So assume, for example, you are having calamine. You're having calamine. It is decomposed. How? Zinc carbonate is decomposed first through thermal dissociation to form zinc oxide and carbon 4 oxide. Carbon 4 oxide also is an acidic gas and therefore should not be released into the atmosphere. So I will be having the decomposition of zinc carbonate, decomposed to give out carbon 4 oxide forming zinc oxide. Now, we have now formed zinc oxide through decomposing the calamine, that is zinc carbonate, or by roasting zinc sulfide. Now, the reduction process now follows. Remember, the major impurity, before we go to the reduction process, the major impurity in this case was lead 2 sulfide. So by the time zinc sulfide was being roasted, the impurity also was undergoing roasting. So the impurity also underwent roasting because it is also a sulfide of lead. Also underwent roasting to form lead oxide and also sulfur 4 oxide. Now, so we have a mixture of zinc oxide and impurity lead oxide. Now, we can do extraction of zinc from an oxide using 2 different methods. We can use reduction or we can use electrolysis. Now, if we use electrolysis, it means we must have electric current. And if you're using reduction, it means we must have reducing agent. Now, allow me to begin with the reduction process. In reduction, we use coke and limestone. Now limestone supplies carbon dioxide. Carbon dioxide supplied by the limestone is reduced by coke to form carbon 2. Now carbon 2 is a suitable reducing agent. Now zinc oxide is therefore reduced by carbon 2 to form zinc metal and carbon dioxide gas. So it will be having coke and limestone. We can say we can be having them here. Sorry, here, coke and calcium carbonate. And eventually we'll be having this one decomposing. As I said before, calcium carbonate decomposes to give us calcium oxide and carbon dioxide. This one I believe you know because it is something that is not being repeated. Then carbon dioxide is reduced by the coke carbon to form carbon 2. Now carbon 2 is used as a reducing agent to form zinc metal. Now this one is known as reduction process. So I will be having carbon 4 because of this, and also we will be having zinc metal. We'll be having zinc metal produced. But remember, it is not pure. Now, the impurity which is now lead oxide, because we have not removed it, we can remove it by adding sulfuric acid. So when sulfuric acid is added here, it means lead oxide will react with sulfuric acid to form lead sulfate. This one reacts with this and water. And remember, this salt is an insoluble salt, and therefore it is a precipitate. It can be removed from the solution, from water. So after having reacted lead oxide with sulfuric acid, it forms lead sulfate, which is a precipitate. And a precipitate is a solid which is insoluble and can be separated from a solution through filtration. And that is why we say, after having formed it, it can be separated since it is what? A precipitate. Now, we are now having zinc metal. But remember, not all the impurities can be separated. Now, I never mentioned a silica. Silica is also an impurity, but a minor one. So we have this one being the major impurity, then we are having the minor impurity, which is silica. Now silica will be removed by calcium oxide. So calcium oxide, which had been formed through the decomposition of calcium carbonate, reacts with the silica to form calcium silicate, which is removed as a slag. Now, this one is reduction process. We can also extract zinc using electrolysis. Electrolysis, we can use it to extract zinc. Now, number one, you must form the solution of zinc. So, sulfuric acid is added to zinc sulfide to form zinc sulfate. And the question I believe you know as a chemist, if you react sulfuric acid and zinc oxide, you form zinc sulfate. Now zinc sulfate is now subjected to what? To electrolysis. How? So the electrolytic cell here in this case is very unique because the anode is made of aluminum sheet. And you put the zinc sulfate in the electrolytic container. And then the cathode is lead with 1% silver. Mark this one clearly. The cathode is made of lead with 1% silver. The anode is aluminum sheet. And then we have current. So electrolysis will take place. And at the anode, we'll have zinc. I will have at the anode. Remember, in zinc sulfate we are having water, and also we are also having zinc and sulfate. And remember, water has got hydroxide ion and also hydrogen ion. So zinc ions will migrate to the cathode. So at the cathode, we'll be having zinc ions, because we have got zinc ions in zinc sulfate. Zinc ions reacting with 2 electrons to form zinc metal. At the cathode we have got, at the anode we have got 2 ions. We have hydroxide ion and sulfate ions migrating to the anode because they are negatively charged, and the cathode is what? Is positively charged, and therefore the negative charges migrate to the anode. But in this case, hydroxide ion will be preferentially discharged to sulfate. So hydroxide ion 4 moles will be preferentially discharged to form oxygen and water with 4 moles of electrons. And therefore, to balance this, we must therefore change this one to be 4 and then here to be 2, so that we have got 2 by this to give us 4 electrons. Then we can balance by having 2. So we are using aluminum sheet as the anode, because if any case we used graphite or carbon, then instead of zinc being discharged, zinc ions being discharged at the cathode, then hydrogen ions would be discharged and there would be no formation of zinc deposit. So for zinc metal to be formed at the cathode, then we must use aluminum sheet being the anode, lead with 1% silver being the what? Being the cathode. So after having obtained zinc, now you can subject zinc to purification process. And that one marks the end of extraction of zinc from its ores. Now zinc has got so many uses. Zinc can be used, as a jewelry. Zinc can be used in so many places, even in the industries. May God bless you. Any question you may ask. Thank you so much.